Okay, so we'll talk about Fourier series. In case যদি ডিসকানেক্ট হয় আমাকে শুধু একটা মেসেজ করে দেয়. Okay, so we'll start with Fourier series. Fourier series is important mathematical physics se. It's like if you're doing your degree course, you have to be very comfortable with integration, differentiation, and so on. But in Fourier series is mostly about integration. So we'll look into certain standard results that we should remember, and at the same time we are also going to look into the derivations. Okay, initially you will feel that we need to do it in detail, but later on you will realize ki a lot of things will be there in Fourier series where you really don't need to do the entire calculation. There are a lot of shortcuts involved. Today we'll try to cover those. So if I talk about a Fourier series, the first thing that we need to understand is a periodic function. So what do you mean by periodic function? It means that you know it will more or less repeat after a regular interval of time. So if you basically consider a sine wave, it will start from the origin and it will go till this point, that means one wavelength, and then again it will start repeating. So that means this is periodic in nature. Now if you start with a cos function, you know that it starts from 1 maximum value, 0, cos 0 is 1, and then you again go and then you get these values, so and so on. Okay, so this may not be correct. So this is how you get the functions. Okay, so this is what is important here, that we understand that a wave function, if it needs to be periodic and we want to represent it mathematically, and the best way to do it is by using some cos or sine function. So a Fourier series, it's a very good way to represent any kind of Fourier function. Okay, and that repeats itself after a regular interval of time. So you can talk about the motion of the planet around the sun. Okay, if you're thinking about this, or if you consider Bohr orbital motion where an electron revolves around the nucleus and so on. So this will keep on going, revolving around the sun, and ultimately it will come back here. So the time in which it completes entire revolution is actually t, and that t is actually something which we call as time period. So if I say it completes one rotation in uh, time t, that means that is its time period. Okay, so that's important. On the other hand, if you think about it in terms of angle, that means let's say it starts from 0, it goes here, so it is 90, then it comes here, it is 180, it comes here, it's 270, and then again it completes the entire rotation. So that means if you consider this entire circle, this is nothing but 2 pi. So that means it has got a period of 2 pi because it is taking an entire rotation and coming back to the same position. So these kind of motions are called periodic motion. Okay, if something is moving straight and it is not coming back, let's say you're talking about a car moving in a straight line, that is not periodic motion. Okay, but if you talk about this motion of planet, Bohr's orbit, okay, or swinging of a pendulum and so on, so these are all periodic. That means they will repeat themselves after a regular interval of time, and if you want to represent them mathematically, then we can represent them in terms of a function. Okay, any function, I think it's clear to us. If we write down a function like y is equal to mx plus c, that means this is the equation of a straight line. So that means this y is nothing but a function of x. Okay, function of x. So that means this is the independent variable. Depending on this value, I can decide what will be the value of y, because m and c are constant. These are slope and intercept. So this is the equation of a straight line, which is the function of x. So here we are talking about a periodic motion, so it will definitely be a function of x, but it will have terms like cos and sine involved. So if I want to include all the possibilities of a Fourier, or of a periodic function, then I should have a cos function, I should have a sine function, and whenever you have a function, that means you see this, it is going from here to here. Everywhere the amplitude is changing. Here amplitude chilo, here it was maximum, then it minimized, here it became 0, and so on. So that means there need to be a coefficient which will actually represent its amplitude, okay, or part of it. So these are nothing but the amplitudes of these terms, okay. And then there might be some constants as well, okay, which does not change throughout the process. So I can take this as a naught divided by 2. So this is a Fourier series, okay. So this is a Fourier series. So what we usually do is, if anyone gives you any kind of numerical, they will give you the function, okay, and then you have to find out the coefficient. So you have to calculate what is a naught, what is an, and what is bn, and after you calculate them, you put it here and you get the series, okay, you get the Fourier series. So for every function the Fourier series might be different. For example, if someone asks you the function is fx is equal to x, so you calculate a naught, an, and bn for fx, and then you put it there, you get the Fourier series for this. But then again, if someone gives you fx is equal to sine x, then your function entirely changes. That means your Fourier series will also change, okay. It depends on the function. Now if we want to calculate these coefficients, okay, these coefficients are very important. If we want to calculate a naught, I have to use this formula. I'll show you that how we got this formula, okay. We have to calculate this formula, which is 1 by pi integration minus pi to plus pi fx dx. Now this is minus pi to plus pi. So if you consider a straight line and you say this is my origin, on this side it goes till pi, and on this side it goes till minus pi, then the entire length, that means this is also pi and this is also pi, and if you add both of them you get 2 pi. So that means the period is 2 pi. It is going from minus pi to pi. That means the total period is 2 pi. And then you write down the function and dx. So that means if your function is x, in place of fx you can just put x and dx, and then integrate minus pi to plus pi, find out the value, and then 1 by pi will be there, and this will give you the constant a naught. So whatever result you get, that would be your a naught. So this is what you get, this is exactly what you have to do for any numerical problem based on Fourier series. That means I have to remember the constants. If I remember the constants, I find out a naught, then I put it here, a naught by 2, okay. Next I have to find out an, okay. Just a second. Okay, so we have found out a naught. So what is an? Next is what is an. So an এর জন্য we have to again take up a formula. So for an, the formula is this. So it is a function fx and cos nx. So if I want to solve this particular problem, then I have to recall, if you remember, integration by parts, okay. Integration by parts is very important, where we consider both of them as different function. Let's consider this fx, which may be x, sine x, whatever, as u, and this can be considered as v, okay. And if you remember, if you want to do integration by parts, we can take u integration of v dx, okay, minus, and then take integration, give a bracket, and then you take d dx of the first function u into integration of second function dx, and dx, finally dx. So this is how you do integration by parts. Now what will be u and what will be v, that you have to choose. You always consider a function which is reducible as v, okay. So it depends, okay, it depends on which one we want to choose, okay. So we're going to see that later, but this is the basic formula of integration that you should know. There are two functions. So in this particular case, if I take fx as u, that means this u would be nothing but fx, and this v would be nothing but cos nx, okay, and so on. So we can solve it and find out whatever is the answer. We're going to see that later. So this is an. So again you solve for a n, you find a value, you put it there, an come. And then finally you find out bn. Bn is 1 by pi minus pi to plus pi fx sine nx dx. So it is easy to remember. Everywhere there is a 1 by pi, 1 by pi, 1 by pi. It is common. Integration is always from minus pi to plus pi. It depends. It might change also, but we are not going to go into that later. Not now. Minus pi to pi, eta minus pi to pi, eta minus pi to pi. There will always be the function fx, fx, fx. But for a naught, it is only fx dx. For an, there is cos x involved, and for bn, it is sin x. So you have to just remember this, and based on this, you can solve all the Fourier series. So this is something which you should remember. Although we can derive it also, but during exam, the chances are that they will ask you to directly derive. Okay, so this is something which you should remember. Very important. So let's find out these coefficients. How do I get a naught as this, an as this, bn as this? Let's try to find it out. Okay, for finding this out, we have to first know certain properties which are actually called the orthogonal identities. Okay, so these are the very important orthogonality identities. These are the integrals that you should know. Use the term useful integrals. These are the integrals that you must know to solve your problems faster. This is fundamental to solving Fourier series. Otherwise you will be in a big loop. You will be keeping on solving the integrals again and again, and you will get confused, you will get wrong answers and so on. Okay, so whatever property we are going to discuss now, this is actually called orthogonality property. And for this, the integers that we are considering, m and n, that means whatever is the coefficient of x inside the bracket n, and x here is m, these values are integers and they are always greater than or equal to 0. Okay, so let's look into this. If you have an integration like this, please remember this. Okay, this result you can use directly, you don't need to do the integration. Okay, we can do it and find it out, of course. Okay, it's not that difficult. I'll show you one at least. So it says that cos mx cos nx dx if m and n are 0. If m and n are 0, so let's try solving this first one. If m and n are 0, I will take minus pi to pi, and then cos of m is 0, so I'll take cos 0. 0 into x is 0, and then n is also equal to 0, so this would be again cos of 0 into dx. So if I see this cos 0 is 1, we already know. This cos 0 is also 1. So that means I am just integrating minus pi to plus pi dx. Okay, and then if I integrate this dx, I will get it as x. Okay, and then I can take the limit from minus pi to plus pi. So if I solve it, I will get upper limit, that is pi, minus lower limit. In place of x, I will put minus pi, so it is minus pi, so it is pi plus pi, which is 2 pi. So this is the result that we have here. Okay, so what you can do, it's not that if you don't know this result you cannot solve it. That's wrong. You can solve it, but then it will take more time. So it is always suggested that you solve it, okay, if you have time. But if you don't have time, or many a times we don't need to solve. Okay, here it is expected you know these standard results, directly put the value, that's it. Next is not equal to 0, so that means it can be greater than equal to 0. So equal to 0, we have seen it is 2 pi. If it is not equal to 0, that means this m and n are equal. Okay, both of them are equal. So let's say they are not equal to 0 and m is equal to n. That means your integration would be minus pi to plus pi. M and n are equal, so the first term would be cos of mx, and the second term would also be cos of mx, cos mx dx. So this is integration of minus pi to pi cos square mx dx. Okay, now we have to solve this to find out the result. So also we have to remember certain standard results. That's very important. So I can talk about cos 2 theta. Okay, we can talk about it in terms of sine 2 theta also, but we are talking about cos 2 theta. So cos 2 theta is cos square theta minus sine square theta. That is the result that we should know. and we should also know that sine square theta, I'm just revising, cos square theta is equal to 1. And then if I put this result here, in place of cos square theta I can write it down as 1 minus sine square theta. So I can write it down as 1 minus sine square theta, and then minus again sine square theta. So that means my result is 1 minus 2 sine square theta. These results are very important, we are going to use it. In a similar way, if in place of sine, if I write down 1 minus cos square theta, then the answer would be 2 cos square theta minus 1. Okay, so this way also we can write it down. So here we have got cos square theta, we cannot integrate this. Okay, so best way would be we have to take this result, cos 2 theta is equal to 2 cos square theta minus 1. So if we simplify this, we can write down cos square theta is equal to cos 2 theta. This will go on this side, so it will become plus, so it will be plus 1, and whole thing 2 cos theta tha na, so ye divided by 2. So that means here we can put this result is equal to, these results you have to remember, okay, that is important, minus pi to plus pi cos square mx. So cos square mx ki jagah we can write it down as cos of 2 theta, theta was mx, in our case it's 2 mx plus 1 and divided by 2, and then dx. Okay, this is simple, we can take the half out. Okay, and then integrate cos 2 mx plus 1. So cos 2 mx dx, if you integrate this, okay, if you recall, integration of cos will give you sine, it is positive, so I can write it down as sine 2 mx divided by whatever is the coefficient of x, so that is 2m, plus 1 dx, so that means it's only x. So for both of them my limits are minus pi to plus pi. Okay, and if you do this is a sine function, sine of pi, it will be 2 pi, it will be 0, minus pi, if you put here again it will be 0, so the sine term vanishes if you put pi, only this term will survive, so it would be half pi minus pi to plus pi, so it will be 2 pi, 2 will get cancelled, finally I will get pi, so you see this becomes pi. So you have to remember these results. I have shown you how you have derived it, but you can remember these results. Next is m is not equal to n. Okay, m and n may not be always equal, they might be separate. Okay, so if both of them are not equal, then the answer becomes 0. That is the simplest thing to remember. This is actually the idea of orthogonal property. Okay, so that's very important. If m and n are equal, they will be 2 pi if they are equal to 0. If m and n are equal but not equal to 0, it will become pi, and if m is not equal to n, then this becomes 0. Okay. Okay, so the third one also you can do the integration and find it out, and you will see that this will become 0, because both the times you can use this formula of this one, and then you can put the limits and values, but then it's pi, cos becomes sine, put the limit, it will become 0. Okay, next for sine I'm not going to do it, you can try doing it. If m is 0 or n is equal to 0, okay, you can get the answer. Okay, both cannot be 0 simultaneously. The reason is, if both are 0, it becomes sine 0. Okay, if both are 0, then this becomes 0, sine 0 is 0, and this also becomes 0, so that means 0 into 0. Now 0 into 0 is undefined, you cannot multiply 0 with 0. Okay, so that's why if m is equal to 0 or n is equal to 0, both cannot be 0 at the same time, that's the problem here. And if m and n are equal but not equal to 0, then you can consider again the same formula, sine square and so on, you can do it, and then you will get it to be pi. And if m not equal to n, this becomes 0. So you have to remember this, this is important. Okay, You have to also remember something which is called as an odd function and an even function. We are going to come to that later. So let's just take one by one at a time. So if you know these properties, orthogonal properties, we can actually find out the value of a naught, a n, and b n. If you there is one more thing that you should know. If it's not cos or sine, it is cos and sine, then cos mx sine nx dx is equal to 0 for all integers m n. So if you consider any integer of m and n, if it is multiplied cos x and sine x, it is 0 because one of them is an odd function. Please remember this. If it is periodic in nature, that means it's a period of 2 pi repeating after certain intervals of time. That means that if you consider sine of x, okay, this is an odd function. If this is an odd function, that means it will be 0, okay. But if you consider cos of x, this is an even function, so this is not equal to 0. This is not going to be equal to 0, okay. So please remember, sine is an odd function and cos is an even function. That is very important. I will give you another example of an odd function and an even function. It simply means this, that let's say I have got an fx which is equal to x square, okay. So in place of x square, if you take minus x square, in place of x, if you take minus x, and then again the square is already there, in place of x I am taking minus x, so this will become again x square. So that means it is again a function of x. So f of minus x is also x square, f of x is also x square. So this is an example of even function. On the other hand, if you take fx is equal to x, and if you take f of minus x, it is minus x. So they are not equal. F of x and f of minus x are not equal. So this is an odd function. So this is how odd functions are defined. That means that if you take sine of minus x, okay, you can understand this in this way. Sine of minus x, it is not sine x, it is minus sine x, okay. It is, okay, this will become minus of sine x. But if you take cos of minus x, this is an even function, so this will become cos x. So that's the idea of even function and odd function. That is something which we need to use. Okay. Now let's go to finding out the coefficient that we said, and let's see how this is derived. So let's find out coefficient a naught. Now we know Fourier series. Our Fourier series was fx is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos nx plus b n sin nx. That was our coefficient of Fourier series. Now what I am doing is I am integrating the Fourier series on both sides from minus pi to plus pi with respect to dx. Here also minus pi to plus pi with respect to dx. Here also minus pi to plus pi with respect to dx, minus pi to plus pi with respect to dx. So I am integrating it with these, okay. So now let's integrate and see what we are getting. So if we integrate the cos term, okay, you can see this cos minus pi to plus pi cos nx dx. Now if you integrate this, you are going to get the answer as 0, okay. You can try it, do it, and you will see that this will actually become 0, okay. It's not very difficult to do. If you integrate cos nx dx, it would be sine nx divided by n, okay, and you have my limit as minus pi to plus pi.
স্যার স্ক্রিনটা গেছে গিয়ে
চলে গেছে, দাঁড়া
হ্যাঁ
let me share. Okay, now visible?
হ্যাঁ স্যার
Okay. So you've understood up to this point, no? এখানে পর্যন্ত বুঝে গেছো তো?
হ্যাঁ
Okay. So next we have got coefficient of a naught. We are finding out. So as I said, we have the Fourier series fx is equal to a naught by 2 plus summation an into cos nx plus bn sin nx. Now we are integrating them on both sides from minus pi to plus pi with respect to dx, minus pi to plus pi with respect to dx, minus pi to plus pi with respect to dx, minus pi to plus pi with respect to dx. Now if you integrate this term, this term, you will see that this cos nx dx integration would be sin nx by n, and limit is from minus pi to plus pi. So you can take 1 by n outside, and then you can take the limit. Limit means you have to take the upper limit, so it would be sine of n pi, then minus sine of minus n pi. Now you know sine of n pi minus n may be any integer, okay? Both are 0. So this is 0, this is also 0. So they are zeros, okay? So that means this is okay, that means this becomes 0. So hence my cos of nx is 0. This again I am telling you, you can remember this, okay? Please don't try to derive it in exam, because it may not be asked, may not be required also. It's just a way to do it, okay? It's better to remember these standard results. Similarly, you can try doing this, okay? And you will see again this will become 0 because it is n pi. So if you take n any value, you will see it will be 1 minus 1. Here it is 0 minus 0 0, it will be 1 minus 1, again it will become 0. So then sine of nx dx will also become 0. So that means here this term becomes 0, this term also becomes 0 after integration. We are left out only with this first term. So that means integration of minus pi to plus pi fx dx is a naught divided by 2, this term, into dx, integration of dx. So integration of dx is 2 pi, we have already seen it is 2 pi. So this 2 and this 2 will get cancelled. I will get a naught into pi. My aim was to find out what is the coefficient a naught. So a naught is 1 by pi integration of minus pi to plus pi fx dx. So this is how you find out the coefficient. So many a times, if there is a basic question of finding out the coefficient of a naught, an and bn, you can use this technique and show it, okay? It's the starting of this. This is all pure maths, okay? Okay, now let's move ahead and see, find out coefficient of an. Now if you remember, okay, this is a trick to remember on how to find out the coefficient of an. If you go at the beginning, we know that the coefficient of an has a term cos nx with it. So that means if I want to find out the coefficient of an, or derive coefficient of an, I will take the same Fourier series fx is equal to a naught by 2 plus summation ax cos nx plus bn sin nx, and multiply both sides with cos mx. So I'm multiplying with cos mx here, I'm multiplying with cos mx here, I'm multiplying with cos mx here, and multiplying with cos mx here, and then integrate it from minus pi to plus pi. So integrate it from minus pi to plus pi with respect to dx, minus pi to plus pi with respect to dx, minus pi to plus pi with respect to dx, minus pi to plus pi with respect to dx. So same thing we are doing, but just we are adding one more thing. We are multiplying both sides by cos mx. Now here, whatever we have learnt in orthogonality theorem, we are going to use it, okay? You see cos and sine, both of them are there, then it is 0. And if you look here, there is one term which has got both cos and sine. So this so easy. This straight away becomes 0. I don't have to worry about it, okay? Next I have got this minus pi to plus pi. A naught by 2, you can take it out. And if you integrate this term is also going to become 0. Okay, we have seen it here. We have seen it. Kahan dekha? Yahan pe. 0. This term is also going to become 0. So this is also 0. That means we are left out with only this term. Only this term needs to be integrated. So I have got this, and then I've got this integration. Now you see that if you consider n is equal to 1, 2 and so on, and if you look into the orthogonality property, you can consider this to be n is equal to m. If you go to the orthogonality property, you see both are cos, n is equal to m, and they are not equal to 0, then the answer is pi, okay? So I am saying m is equal to n and not equal to 0, because if m is not equal to n, the answer is 0. That means I am losing that coefficient. That coefficient does not exist, okay? But we have to find out a form for this. So that means m is not equal to n can never be the case. The only case possible is m is equal to n, okay? And if m is equal to n, and both of them are equal to 0, then it is 2 pi. But if you look into the series, the n value does not start from 0, because obvious sine of 0 is 0, right? So that term vanishes. So n does not start from 0, n starts from 1. So that means n starts from 1 for one condition. Second condition, m not equal to n cannot be there. This condition cannot be there because this is for 0. That means the only condition I am left out with is this, m is equal to n and not equal to 0. So the only condition is m is equal to n, this m and n are equal, and they are not equal to 0, okay? And that means that I can get rid of this summation as well, because every time I'm going to get the same result, okay? So because this is a cos function, so let's say m and n are equal, so I can just take cos square mx, and we have just now seen, okay, if we integrate cos square mx, what was our result, okay? If we integrate cos square mx, our result was pi. But this we don't need to do, we need to remember this pi, okay, this result. So let's use this. So this is just pi. So that means this term is am into pi, am into pi. So this side it is am into pi, this side is this integration. I need am, so that means I will just divide it by pi, integrate it from minus pi to plus pi, fx cos mx dx. That's it. So that's how I find out the value of am. And please remember, m cannot be equal to 0, m is not equal to 0, m is either equal to 1, okay, m is either equal to 1 or m is greater than 1. Similarly, you can do it for coefficient of b and x. I don't think it's difficult. Same thing, you have to multiply it with sine mx on both sides now. So if you take this, I'm multiplying here by sine mx, here by sine mx, here also by sine mx, and here also by sine mx. This one too easy, cos nx, sin mx, both are even and odd terms are there, so directly I will get 0, okay? Second one is this one also, if you check and do the integration, this result will also become 0. So that means I am only left out with this. In your exam, if questions are asked, there also you can say that this is becoming 0, this is becoming 0 straight away, standard result, okay? You can show maybe 1 or 2 steps depending on the marks, but if the marks are not much, don't spend time on them, directly say it's 0. And for this is sin nx, sin mx, here also the same case, n, m both must be equal and cannot be equal to 0, and they have to be 1 or greater than 1. So that means I am giving only one condition here, so I can write it down as minus pi to plus pi sine square mx dx. Integrate this using the same formula, and that is going to become pi, because sine mein to, you know, it's easy. Sine mein, if you check the orthogonality condition, it is 0 here, 0 here, only here you will get a result. So that means this is the only possibility, which is pi. So cos le lo ya sine le lo, it is always going to be pi if m and n are equal and not equal to 0. So that's how you find out the coefficient of this. So this is again pi. So b is 1 by pi integration of minus pi to plus pi fx sine mx dx. So is it clear, Kushit, the coefficients?
Yes, yes, sir.
Okay. So this is the fundamental of Fourier series. Based on this, they can give you any question and you can easily do it. But then most important is you should know integration. That's very important. The more you know about integration, the more you practice integration, Fourier series becomes easy. So a quick summary, this is my Fourier series, okay? This is my Fourier series, and what I should know is what is A0 if I want to solve a problem, what is AN and what is BN. We have already seen how we get AN, BN and A0, but this is the formula that more or less we should know. We are going to anyway use it, okay? There will be change of limits as well many a times, but we are going to see that later. Sometimes it happens that it has got a period and so on, so you have to change the limits in that. So I've taken 3 most basic problems to solve in Fourier series. The question would be you have to find out the Fourier series, that's it, okay? So the question is you have to find out the Fourier series. তার মানে I have to find out this series, this length of series, 3 terms. That means I have to find out a naught, an, and bn, and put it in this equation. You have to remember that this is my series, okay? So the first step is, this is my series. I should know this. Solve, okay? These are the steps we need to do. A naught, an, bn. Okay, so we are going to use these formulas that we have at the bottom to solve a naught, an, and bn, and then put these values of a naught, an, and bn in series. Then only your answer is complete, else your answer is not complete. Your job is not just to find out a naught, an, and bn. Whatever value you find, you put it here, and then only you know that you have the Fourier series. So you put a naught, এখানে already divide by 2 আছে, so you have to use that divide by 2 here when you put it here. You put an and then puts cos nx, bn sin nx, and so on. So let's take one very simple example. The question would be very simple, okay? You have to just find out the Fourier series fx is equal to x, that's it. So fx is equal to x is my question, and the limit would be minus pi to plus pi, or they might say it is having varying 2 pi periodically, so you can directly take it from minus pi to plus pi. You can also write it from 0 to 2 pi, okay? You are going to get the same answer, but the point is that they are going to specify the limit, okay? And it's always better to take minus pi to plus pi, okay? It becomes easy because you can use your orthogonal properties and so on. So let's check this. As I said, if we have an odd function, so this is odd function because f of minus x would be minus x, not fx. So if it is an odd function, if you take the cosine of the coefficients of an and a naught, they are always going to be 0 because this is an odd function. Directly check that, okay? Directly check whether it is an odd function or an even function. If this is an odd function, you put the value, you are going to get it 0 for odd function. This will also be 0 for odd function. So straight away get rid of this, okay? You don't have to think about anything. You go directly to this, you check this, okay? If fx is odd, this both becomes 0. Here what happens is fx is odd, but this is also odd, this is also odd, so both of them becomes an even function, okay? So that's why this does not become 0 if you integrate it. So odd function মানে directly 0 হয়ে যাচ্ছে, an and a naught I don't need to calculate, you can directly write it. But if you are getting more marks, you know, if more marks are given, then you have to just show the steps. Like for example, if I want to find out a naught, I know this is 1 by pi integration minus pi to plus pi fx dx. So that is my general relation. I know the function and I put the value. So I'll put the value, I'll put 1 by pi integration minus pi to pi fx. Now what is fx? Is x, our function is x here, into dx. So it can be written as 1 divided by pi, and this I can take it as x. So x, if you integrate it, it's nothing but x square divided by 2, and this would be nothing but minus pi to plus pi. So 2 का तो कुछ लेना देना है नहीं, तो I can take it out. So it will be 1 divided by 2 pi, and then upper limit minus lower limit. So upper limit is x square, so that is x की जगह pi, so it is pi square, minus lower limit is minus pi square, so I'll take it as minus pi square. So you can see this is 1 divided by 2 pi, and within bracket it is pi square minus pi square. So pi square minus pi square minus 0. So you integrate it, you take time, and then you will get it as 0. So sometimes what happens is this might be a question where they're giving you 5 marks. So if it's a 5 marks question, I would prefer you won't use this idea of odd function. You know it is 0. You should know it is 0, but you should show the steps, okay? Because 5 marks है ना, तो थोड़ा तो दिखा ही सकते हैं. Similarly for an also, you can calculate and you will see it is 0. So I'm not going to show it. Let's do it only for the sine function. So bn is the only term that survives. It is 1 by pi integration of minus pi to plus pi x sine nx dx. X sine nx dx. So this x sine nx is even because x is odd, sine nx, sine is odd, so odd even becomes, right? It's normal. So there is one more property that you can use. If we have the function as even, okay, this is entire function is even. So ये पूरा का पूरा even है. And if the limit is same, minus pi to plus pi, they are both pi's, but it goes from one extreme to the other extreme, minus pi to plus pi, then you can change the limit from 0 to pi and multiply it with 2. That is a property of integration that we can use. Even if you don't use it, you are going to get the same result. So please remember, it is not necessary that you should use it, but if you know the property, it helps you to do your integration faster. That's very important. So I can take minus pi ki jagah 0 to pi, and then this will be 1 by pi, and multiply it with 2 because you are going to write it 2 times. That's it. Okay, so 2 by pi, 0 to pi, x sine x dx. So let's try to integrate this. Now if I want to integrate this, I have to use my integration by parts. Integration by parts mein matlab, one I have to consider as the first function. Let's say x is the first function and v is the second function v. So u is x, okay, and your v is sine x. Okay, so even if you don't do these steps, you can still do it. Okay, it's not very difficult. Just take the first function. The first function is x. Okay, कुछ करने की ज़रूरत नहीं है. Then integration, you take 0 to pi. Okay, 0 to pi. This 2 by pi is there. I'm just integrating this part. Okay, just integrating this part. Okay, so this is 0 to pi, and then you can take it as sine of nx dx, and then you can take a minus here, and then you can integrate here, then it is 0 to pi, and then d dx of x. You always take the reducible function as the first function, where if you do the d dx, it reduces so that it minimizes the integration. Sine nx dx dx. This is my integration result. Okay, let's do it. So this would be x, and then if you do it, this would be cos of mx or nx, whatever, divided by n, and it is 0 to pi, 0 to pi, minus this is 0 to pi, and d dx of x is 1, so this goes, this is 1, right? And then sine nx dx, so this will again become cos nx divided by n into dx. Okay, and I need to just integrate this. So if you take this, this would be x divided by n, and then you have to put the limits here. So cos of m pi, cos of n pi, minus cos of 0, cos of 0. So this would be one result on this side. Here if you take cos, it will become sine. Okay, and sine of n pi is 0, and at the same time if you break this, this will become sine of n pi is 0, and sine of 0 is also 0. So this second term anyway vanishes. Okay, so this second term anyway does not exist. So this term, if you check, okay, this becomes cos 0, which is nothing but equal to 1. So it is cos of n pi minus 1. So what is cos of n pi? N pi means you take the value of n. If you take cos of pi, this is minus 1. If you take cos of 2 pi, this will be plus 1, and so on. Okay, so that means if there is an odd number, you can take the power as 1. If there is an even number, you can take that even power of minus 1. So minus 1 square will become 1, right? So that will remain the same thing. So that means if I write down cos of n pi, okay, this term is nothing but minus 1 to the power n. Okay, so that's important. So if I do this integration, please remember this. Okay, we have to do the integration. I don't know, I think there's a mistake here. Let me just check. Okay, this is 0 to pi, this is 2x divided by n. Okay, okay, so I got x cos nx divided, sorry, I did not put the limit here. sorry, this x is also there, na? You have to put a limit here as well, okay? So this is also 0 to pi. So what I can do is, I can just do the correction here. Let me just take the eraser. So I did not put a limit on this x. So if I put the limit on this x, I can take 1 by n, that is out. X is not out. So this is x cos mx. So x की जगह pi cos of n pi minus x की जगह 0 cos of 0. So 0 into 0 0. So this second term vanishes. I am left out with only this. So this is pi divided by n into minus 1 to the power n, because this term will become minus 1 to the power n. This will always be minus 1 to the power n, and then there is a pi. So it is pi by n minus 1 to the power n. So it is pi by n minus 1 to the power n. Okay. So what happens here is that if you take this bn, you have to multiply it with 2 by pi. So you multiply it with 2 by pi, because I have integrated only this part. Okay. So you have to integrate this, and there is an integration of sign. So there will be a minus sign. Sorry, I missed out the minus. So there will be a minus sign. So we have to just remember cos x dx is sin x, and integration of sin x dx is minus cos x, right? So that I'm integrating sine here, so I have to take minus. So minus of pi minus 1 to the power n by n, 2 by pi, this pi and this pi will get cancelled, okay? And then there is an n here, okay? There is 2 here, okay? You can take this as minus 1 you can take. So you can take minus and then minus 1 to the power n. This minus can be written as minus 1, and then this is minus 1 to the power n. So if the bases are same, powers are added, so I can simply write it down as minus 1 to the power n plus 1. So that's why you get this as minus 1 to the power n plus 1. Then there is a 2 divided by n. So this is my series. Now what I do, I replace it. So replace में क्या हो रहा है? You have to put fx first. This is my series fx. So my fx is x. So I'll put x here. This becomes 0. This becomes 0. I have got bn here, which I have just now calculated. So this becomes 0. The first two term becomes 0. On this side, this is x is equal to 2. Summation will be there. N is equal to 1 to infinity minus 1 to the power n. Okay. So if you check this, we are left out with fx. an naught and an are 0 is equal to 2 by pi summation. Okay. Let's take the result, standard result, 1 by pi summation n is equal to 1 to infinity, and then bn sine nx, sine nx. So that means this would be nothing but equal to 1 divided by pi summation bn. So bn we have just now calculated as this, so we will put it as 2 minus 1 to the power n plus 1 divided by n into sine of nx. Okay. So there's some mistake, it seems. I think it has missed divided by pi here. This divided by pi should be there. So I think that was missed. Yeah. So the final answer would be nothing but 2 will come out. So it would be 2 divided by pi summation of minus 1 to the power n plus 1 divided by n sine of nx. There should be a pi here. Okay. Oh, sorry. There is no pi here, no? Oh, there is no pi, sorry. That was for bn, correct. Sorry, there is no pi. That's correct. Right? तो इधर पाई नहीं आएगा, क्योंकि अपने को तो सीरीज़ में लिखना है ना, सीरीज़ में पाई है नहीं. Sorry. So this is my result. So this is how you use the Fourier series okay, to solve problems if the function is given to you. Now there can be different kinds of function. These problems you can try, okay, different kinds of problems. For example, the function is, let's consider this, okay. If you consider this is 0, this is pi, and on this side it is minus pi, and this is the function, okay, this is the function. These are the angles that we have. So this function says that it is 1 from 0 to pi. From 0 to pi this is 1. Let's say this is 1. Yeah, here it is 1, and let's say here it is minus 1. So from 0 to pi it is 1, and from minus 0 to minus pi, okay, it is minus 1. So that means this is this. So many times you may not be given this function, okay, you might be given just a graph. So graph like this, and then you have to realize that what is the function. So function is this: from 0 to pi it is 1, and from 0 to minus pi this is minus 1. Now for such function, if you want to compute this, you have to take the function value and do it, and it usually is easy. It's usually not that difficult. I'll tell you why. Because here the function is odd. You see why odd? Because if you take the positive values, it is positive. If you take the negative values, it is negative. Okay, if you take 0, you take pi, okay, let's say it's pi, it's 1, but when you take minus pi it becomes minus 1. So that means the function is not the same when you take plus or minus. Okay, in general, if I consider this, let's say if I take pi, then my answer is 1. It will remain as 1 always. Okay, but if I take minus pi, then the answer is minus 1. So that means this and this are not equal. If they are not equal, that means it's an odd function. So that means we know that if it's an odd function, okay, again you can do it and try it, a0 and an are always going to be 0. Odd function के लिए 0 है, तो नहीं चाहिए कुछ करना है. Here also you have to just find out for bn. Just find it out for bn. Okay, but then there is a trick here. You have to split this integral. Okay, 1 by pi will be there definitely. Why do you need to split? Because the limits are different here. It is 0 to pi and minus pi to 0. So that means my first limit would be 0 to pi, okay, or maybe I'll start it with minus pi. I'll start with minus pi, and then I will go to 0. Okay, I will start from here and I will go till 0, and then I will write down the function, entire function, plus, and again I am going to integrate. Then I am going to start from 0 and then go to pi. So I am going to start from 0 and then I am going to go to pi. So that is how you separate out the integrals if the limits the limits are different. Okay, so minus pi to 0, 0 to pi. So you can split the integral. You can take these two results and do the integration. I'm not going to solve this. This is easy. You can directly take it as 1 by pi, and then this is just you have to integrate sine nx dx. That's it. So if you integrate it, you're going to get one term 2 by pi, 1 minus cos nx n pi by pi. So you can try it and do it, but always remember this one more result, very important. This one you have to remember. Cos of n pi is always minus 1 to the power n. So we integrate this, get this, put it here. Okay. So this is how you solve it. Try solving, okay, both of them. If you add and solve, you get this. Okay. So this is your bn, 2 by pi, 1 minus 1 to the power n divided by n. Okay. So you can write it out in different forms. Okay, you can directly write down this, that's fine, or else you can use this also. Okay, because what happens if n is even, then this becomes 1. So it becomes 1 minus 1, which is 0. So that means if we want a non-zero coefficient of bn, it has to be odd. N has to be odd. Okay. So if n is even, okay, if n is even, then this entire term becomes 0. Okay. So that means n needs to be odd to get a term, and odd means you can directly write it down as 2n plus 1. So n we have already used, so I am writing down it as 2k plus 1, where k value will start from 0. Okay, k can start from 0, because if k is 0, then n is 1. If k is 1, n is 3, and so on. Okay, so you can take it start from k. So that means we can write it down as b of 2k plus 1. So in place of n, you can put it as 2k plus 1. Okay, so that is possible, and then you can do your integration and so on. Okay, so it's not that complicated. So if you take this bk now, in place of n I'm going to take b 2k plus 1. You can do it this way, or you can directly leave it here as well. Okay, it's not entirely wrong, but it's not super simplified. Okay, we need to simplify this, so I can write it down as 2 divided by pi, and this is 1 minus this is minus 1 to the power 2k plus 1. So n की जगह 2k plus 1 divided by n, so that is there, that is again 2k plus 1, sorry, n again becomes 2k plus 1. So on the top, at the bottom it's there, pi into 2k plus 1, here it is 2 into 1 minus, you see this is minus 1 to the power 2k. Okay, and so if you can separate it out, okay, the bases you can take separate bases. 1 minus, first term would be minus 1 to the power 2k into minus 1 to the power 1. You can write it like this. So this is the same, 2 divided by pi into 2k plus 1. But you see this minus 1 to the power 2k, that means you start from k with 0, so it is 2 into 0, 0, so minus 1 to the power 0 is 1. If you take k value as 2, it will be 2 into 2 4, so or 1, you can take it as 1, so it will be 2, so minus 1 square is 1. So this term is always going to be 1, positive 1, and this term is minus 1 to the power 1, so this is going to be minus 1, so it will be minus 1 1 minus minus 1. So here you will get the term as 1 minus and minus 1. पहला term ये वाला तो 1 है, ये वाला minus 1 है, so it will be 1 minus plus 1, so it is 2, so that means it becomes 4 divided by pi into 2k plus 1. So that's why it is written like this. So that is your bn. तो बस उसको बिठाओ and then you get your answer. Okay, forget about this. Okay, they have written it as the harmonic form. I don't need to do that. We can directly put out the value here in this particular Fourier series. कहाँ गया मेरा ये वाला Fourier series है, ये Fourier series. So what was our fx? Fx was 1 and minus 1. a0 an are 0, and in place of bn you can take it as 4 by pi and 2k plus 1 और ऊपर, बस that's it, into sine of nx. n का value again 2k plus 1, so you can put the value of n. This is what they have done, n की value 2k plus 1, 2k plus 1 into x, and simplify it, put it there, you get the answer. So this is the Fourier series. So this is for this function. Okay, and call it as a square function. Okay, so that's there. There are certain functions which are called step functions as well. So next class we can solve more problems and check.